almost fall off, break my neck trying to get this to work, and it looks like it's tilted again. Maybe not. Maybe not. So, the sphere density homework, some people have already turned it in, so good job for y'all. I don't think we set it up as well as I had planned in the lecture, because I thought that we had done so in the previous lecture, in the prior lecture. So I want to go ahead and do just enough of it to get a good start. We did not do that last week. I just checked the notes, right, and we haven't actually written anything that would serve as a template for this. We talked about case and stuff. Is that true?
It's on J, I believe.
Yep, lecture J.
That's what I used when I wasn't here for the lecture, so I think it's pretty decent.
Oh, okay, then we don't need to go back and do it. Why am I so...
We didn't use switches though.
All right, so we are done. Good, okay, good. So break and default, every case should have a break unless you're doing something pretty strange. And what that's strange is if you're using fall through. So for example, if you type in an A, when it comes in here, switch on the choice, case A, prints out, you entered an A, break. Without that break statement, it would fall straight through and also print you entered a B. Maybe that's great. Probably not. Let's give an example of when it might be useful, though. If we have, back in olden days when you had your little flip phones and you wanted to text somebody, we've done the thing where we turn the letters prefix into a number, but we have not done where you type in if you want an A, you'd press 2, but if you want a B, you'd press 2, 2, and if you'd want a C, you'd press 2, 2, 2. Right. We have not done that yet. And so we could do that with switch cases, and it would be an easier structure to implement, perhaps, maybe not, than if we did it with if-else. Let's go ahead and give an example of how we would do that. So the problem is, as defined, text messages that you sent to each other on your phones in the early 2000s before you got your iPhone or your Android. If you wanted a K, you'd press 5 2 times. If you wanted a W, you'd press 9 1 time. If you wanted a Z, you'd press 9 4 times in a row.
You had to work to send messages.
Yeah, you really had to work at it back then. So,
Predicted text was genius.
yeah, some people could just go right incredibly quickly through it. So let's set up so that we can at least handle the A and the B and the C. How am I going to do that? I'm going to set it up so that if they type in a C, we print out a 2. If they type in a B, they print out a 2. If they type in an A, they print out a 2. But we use fall through so that C is above the B and B is above the A, so that if they type C, it prints 2, it falls through to the B case, it prints another 2, it falls through to the A case, it prints another 2, and then it breaks. And they have an example of something similar where they're doing features on a television set. And you have the high features and the medium features and the low features. And so the best TV has the high ones, and then it prints that out, and it comes to the next one because there's no break, and prints out the features of the medium one, and then it prints out the features of the low one. So we're going to do something similar. How lucky y'all are who are using your laptops, and when you create a project, it fills in all the boilerplate for you. However, it does not put the cool stuff like the using math defines and CMath and stuff like that, so there is that.
I just went ahead and created a template for that.
Oh, you got that in there? That's cool. That's cool.
Project template.
Yeah, that's cool. All right, so lecture L.cpp. There's my boilerplate. We can make it a loop to where we ask them for a character that they want to send, or type in a, I don't know, period to exit, something like that. So let's get a character for our input, just like we did the other time. Let's read it in the first time, or we could use a while true and then break out if what they typed in is a period. So while parentheses true, system.out, wait, that's Java, cout less than, enter a letter or dot to quit. Space, end quote, semicolon, and cin dot get parentheses in parentheses semicolon. Did we not decide that that's how you get a single character? I believe that's the case.
Yep.
And let's check to see if it's equal to a period. If it is, we're going to break. So if ch equals single quote, because it's a character, dot in single quote, in parentheses, break, because we're done. And it's not called ch, it's called in. Tell you what, that's going to drive me nuts. I'm going to change in to ch, just because that's burned in my brain better, so I'm going to have to change it everywhere I've used it. Char ch, cin dot get parentheses ch. If ch is equal to a period, break, and then we can set up our switch. Switch parentheses ch in parentheses semicolon. Now it'd be cool if we could convert that character to an uppercase letter, so that we'd only have to check for A rather than checking for uppercase A and lowercase a. But not being willing to go and look that up, I'm just going to go ahead and do it like this. So a case of a capital C, colon, or a case of a lowercase c, colon, we print out a 2. Notice that the 1 does not have a keypad value at all. I mean, there's no letters associated with 1. That's because 1 was such a special value. No telephone number ever started with 1, no area prefix, ever started with 1, because that's the key that indicates that it's a long distance number. So you were never supposed to type it except as a signal to go, back in the old things. So let's in one of those cases, we're going to cout a 2, but we're not going to break, because if we want to print out 2 more 2's, so on the next line, case B with apostrophe single quotes around it, or case lowercase b, colon, cout another 2, this keyboard. My fingers hit the wrong keys on it. It's all the keyboard's fault. It's not mine. Case uppercase A, colon, case lowercase a, colon, cout less than 2, yet again. And after our switch is done, let's go ahead and cout just an ENDL, so we'll be on the next line. Cout less than ENDL, like that. And let's add our default case. They type in something we don't know. So case, but no, excuse me, default colon, cout unexpected key. honestly don't remember how you sent punctuation on one of those things. I think you had to press some button that switch the keys over into something else. Anyways, unexpected key, \n, end quote, semicolon. Alright, it's nagging me that I didn't remember how to convert that character to an uppercase character, so I'm going to go and look to see if I can remember. To upper C++. Convert C to its uppercase equivalent if C is a lowercase letter. Alright, just like that. And what header file is it in? It's in standardIO.h and ctype.h. So if we wanted to, we could do this. ch equals to upper parentheses ch in parentheses semicolon. And if it tells us that that's an undefined function, then we'd have to go and add the correct #include for it, which apparently would be among these two. stdio.h and ctype.h. If you see .h though, it refers to a C header file rather than a C++ header file. So I'm hoping that that function is available to us inside one of the functions that we're already handling here. First I'm going to compile, see if that's the case. If it compiles cleanly, no errors. Alright, well let's find what library it's in. I'm just going to come up here, highlight it, right click on it and do go to definition. I want to see where it's defined. And it's inside the ctype.h file, which seemed magically to have been imported by some miracle automatically. Okay, well I'm not going to trust importing it by miracle, so I'm going to go ahead and add that up here. #include C type.h, and you can guess what C type means, character functions. And there's lots of them, right? To upper, to lower, etc. Now that we have that, we could get rid of these lowercase versions, right? We don't need them. I'll leave them there anyways. All right, so enter a letter. Well, I've only got one letter or three letters working, C, B, and A. So A should be 1, 2. B should be 2 2s. C should be the third 2. Well, isn't that unexpected? No pun intended. Why is it printing that out?
You didn't break it.
Because I didn't break it. Okay, right. And then you have to put a break on the A case. It fell through into the default clause as well. Now, one of the odd things about the C# language that Microsoft invented to compete with Java after there was a lawsuit between Sun Microsystems and then about their weird version of Java, then you have to put break. Fall through is absolutely impossible to implement in that language. And yet it's a useful thing, although it looks kind of odd. You know, it's kind of strange, but it's a useful thing, because if you weren't going to use fall through, you might just want to use if else's. All right, try it again. A, B, C. It's accepting my carriage return as a keystroke. Did we have this problem last time? I don't recall having this problem last time. I'm going to print out what CH is. I'm curious about the character value of it. So just as a debug step before we switch on it, I'm going to print out its ASCII value. So C is a 222, and then it's a 10. And what's a 10 on the ASCII chart? A line feed. Tell you what we're going to do. We're going to say that if it's less than a valid ASCII character, we're just going to continue our loop. Not sure how we're going to do that yet. Why are we having to do that? Did we not use get key in our last lecture? Or get, I mean. CIN.getCH. I guess we just didn't loop. All right. Here's a moronic way of doing it. Just declare a junk character to hold the carriage return, and then use CIN.get to clear that. Now that's moronic. We should not have to do that. I think it would fix the problem, but I'm rebelling at the thought of doing it that way. All right, I may show you a different way of doing this rather than using .get, because .get seems to be persnickety. Okay, that did fix the problem. Are we willing to be satisfied with that, or do we want to switch over to doing it probably a more reliable way? The more reliable way to do it would be to read it into a string and then grab the first character of that string. That would probably be the best thing to do. So I'm going to change. Now I guess I'll leave it CH, but after it says enter a letter or period to quit, we're going to need a string to read that into. So string S, CIN greater than S. I'm going to delete all of that stuff because that was just confusing me. And then CH is equal to S subscript 0 in subscript semicolon. Get the first letter of the string. That's what that means. So if they type in more than one letter, we're going to ignore it all. And it might be cool to try to write it in such a way that, you know, it would read in the entire string, that we would use a loop to step through it and get, you know, 111, 33, 22, 555, 66, you know, print everything that we need to out of it. That'd be cool, but just for now, let's see, make sure that this works. Okay, I want to do a C. Great. Oh, I still have that extra print in there. I'm about to take that out. Okay. So where's my print statement that's messing us up? Right there. And really, we don't need to be converting it to uppercase because we are checking upper and lowercase. But I'm going to add a comment here as to what it does and comment it out. And now that I've been making edits up and at the top and at the bottom and scrolling around and doing stuff like that, I'm going to pause and make sure it's working for y'all. Well, it doesn't need to print hello there, does it? So we could do the same thing with the next three letters, could we not? We could go and implement D, right? F, E, and D need to print out threes. So I could just copy this entire block here and make it FED 333. So I copied those three lines. Notice I'm getting errors here because now we have duplicate cases. You can't define two cases with the same letter with the same value because why would it know? How would it know which one to jump to? Of course, that was not my final goal. And for each one of these cases, lowercase f, lowercase e, lowercase d, we wanted to print out a 3. Like that. Right? My mind is contemplating horrible things like turning this into a function so that we could just pass in that single character into the function. Maybe we'll think about that. I actually think that's worth doing. Okay. Trying to figure out where would be the best place to leave it. How about there? All right. Just getting syntax errors and vanquish. We're hoping vanquish. Oh, way too good at typing. No complaints. Alrighty. Okay. So what have we done since I accidentally forgot to unpause it? We turned this into a function called void print keypad character. Char C, and then we added a new case so that if they type in a space, then we'll print out a 0, and we move the entire switch block into that function. And then down here, this is how we have changed our input so that we can read in an entire line of data, including spaces, and process each and every letter in the line. So this gets our line of data. And then this for loop, which goes from I up to the length of the string -1, and I'll come back and mention why that -1 is important. For every character in that string, we store it in the variable ch, and we pass ch to the function so that it can be printed out. And we really don't need to print hello there, so why don't we print done? Okay. And you can look in your notes and find that. I wish I'd had the recorder going, but I think that's pretty clear. So going back to the PowerPoint. We know what default is. It says optional but recommended. I totally agree. Even if you think you handled every single possibility, go ahead and put some kind of default that'll print out an error message on the rare occasion that one of your users manages to figure out a way of entering data. So for example, once we're done with, our program, our text program, somebody may type in a question mark, right? And if we had not had that unexpected key, then it would not print anything, which might be an acceptable response, but on the other hand, they probably need to be told. Okay, so switch statement. The break statement, we know what that does. Using switch and menu systems, we have done this. You just display a list of choices. You get the menu selection, and you use that input as an expression in a switch statement, and then you can execute new statements as the case is. Each menu would trigger another case. More about blocks and scope. The scope of the variable is a block in which it is defined, from where it is defined to the end of the block, to the closing brace in which it is defined. And we've talked about this before. This character here, scope, is from this closing brace, this opening brace, all the way down to this closing brace. However, it cannot be accessed inside of any other function. If I put there, I'm not going to be able to get to ch because this is the wrong scope. We're in the wrong context to be able to get it. If we wanted to be able to get that character, we would need to define a parameter variable that would accept it, and we would need to then pass it in. Or you can make a variable a global variable, but that is considered in poor taste. Just run with that. Try to avoid global variables. How do you make a global variable? You move its definition outside all of your functions and probably above all of your functions. There. Now that variable is global, and I would not necessarily even have to pass it in as a variable right there. I'm going to be undoing these changes lickety-split, but the code would work now just as well as it did before, because main would set the value of ch right there, and then when we call it, okay, the compiler is yelling because we're passing in an unwanted argument now. Why is it unwanted? Because we're not accepting it anymore. So I'm going to undelete that as well. So this sets the value of ch, that global variable, and then it calls print keypad numbers, which runs up here and uses a value of that ch. So ch is shareable between both of those. And one thing people do to indicate that it's a global variable is they use some kind of naming convention where they either begin it with G underscore or they end it with underscore G to indicate that it's a global variable, just so that it looks really blatantly obvious that that particular variable was defined somewhere else. Now let's see if I can undo all those changes. I think I've done it. Okay. So this variable's context is only from here to that closing brace. We did not need CH to be hanging out this whole time. We could have just created it here because that's the only place it's where it is used. So one school of thought is to declare your variables as close to where they are used as possible. Another school of thought is some people like to declare all their variables up at the top of the function, right, well before they used it. And if they were going to do that, then you could put string s here rather than do that, right? I guess if you wanted to take that to an extreme, you could declare int I right there. I'm more of the thought that you declare your variable as close to where it's needed as possible, unless there's a strong need otherwise. And in this case, I don't think there is. I think I would cut that and paste it there. And I might add a comment. Holds the character to translate. String s is user input to translate. Whatever. Should probably come up with better comments than that, but at least that's a start.
Could you just initialize it on that array?
Yes, you could. Translate every character in the string. And you're absolutely right. We could do it this way. Get which character to translate. Okay, I think I'm happy enough about those comments now. I think we already have a pretty good intuitive feel for what scope means. This says your variables are usually defined at the beginning of the function. Well, that's just what I was talking about. You can declare all your variables at the beginning of the function, or you can declare them right when you need them. That's the alternative. Be defined close to their first use. That's what they're doing here, right? They did not define years at the top. Instead, they waited until you were about to input it. So variables with the same name. You can do that, and it's not recommended. If it's in the absolute same context, you can't. I can't come here and do this and create a different variable that has the same name. Now, I could lie. I could be lying. Maybe that's going to work. No, that's not going to work. But if this was inside another block inside it, I'd be able to do that. I could give it a different type. And that actually will compile. And if you change CH here, like if you say CH is equal to 987, or even if you declared it as the same type, you know, and you said the character was now 9, by the time you get out of here, if you printed out CH, it would equal what it originally did. This change, this variable only exists between these braces, and by declaring this one, you're effectively hiding this one for this block of code. This block of code can no longer access that variable. Any changes to CH will affect this memory space, will not affect that one. Is that a good idea? Why would you rely on that? I never would, but you can. Many languages will not allow you to create multiple variables at all in the same context. This one does as long as you're in a subblock, if you're not in the same block as the variable in which it's being originally declared. So this hides the original variable CH. Any changes to that variable CH that occur in here will not be accessible down here. If we printed it out, it would be its original value that had been assigned there. So, not a good idea. I would agree with that. Two variables with the same name. I've already given you an example. Okay, so we're done with chapter 4. Take a vote, y'all. Do y'all want an exam on the Thursday before break or the Tuesday after break? Y'all have an opinion? Wave your hand if you like it before the break. Nobody, one person. Wave your hand if you like it after the break. Wave your hand if you didn't wave your hand either way because you don't give a hoot. All right, let's do it after. So we're going to set the exam for the Tuesday after the break. It's going to cover primarily chapters 1 through 4 because I don't like introducing stuff, you know, and then immediately having an exam about it. So the exam will be over to chapters 1 through 4. What's the date? Is break not, help me, is it from 16 to 20? And so it would,
it's from the 16th to the 20th.
okay, so it would be on the 24th.
Mm-hmm.
All right, let's roll with that. And we'll do a review the Thursday before break. And if you skip class because you're going on break early, then watch the review video, okay? But be that as it may, we got to keep plugging away, so let's go to the next PowerPoint.
Is the exam something we're going to do in class, or?
We will do it in class. If we were meeting only once a week, I'd make you go to the library to do it. But I figure since we're meeting twice a week, we can go ahead and afford to. And so the advantage of that is if you take it in class, I'll be here to answer questions. And sometimes if somebody asks me a question and I think the question was too squirrely, I'll give the answer to everybody. But if you can't make it that day, don't sweat it. You'll just take it at the Learning Resource Center later that week. Loops and files. We've been using plus plus already. I'm pretty sure we've seen VAL plus plus is the same thing as VAL equals VAL plus 1. Plus plus can be used before or after the variable. It's called prefix or postfix. And they do the exact same thing, but they do it differently. So there is a key difference we need to understand about that. I guess we could just enter it into our code to prove the point, so you don't just have to believe me. How about up here? Int x equals 1. And then cout less than x plus plus less than ENDL. And then let's reset x to 1 again. And then cout less than plus plus x less than ENDL. And believe it or not, we're going to get two different things. Here's what you might think you're going to get. And it's actually the way it's going to work here. You might think it's going to print 2, right? Because this changes it to 2, and so that's what's going to get printed out. That is true if the pluses precede the variable. Pluses in front of the variable mean do it right away. Make that the very first thing you do before anything else. If the pluses follow the variable, if that's the postfix or the suffix or whatever they called it, then it waits until the output has been generated before it gets incremented. So by the time we're here, the variable is still going to equal 2. And that's going to be the case here as well. It's going to equal 2 here. But this is going to print out 1 because the plus plus does not happen until the end of the command. Right? So it's going to write out 1, and then it's going to sneak back over here and increment x. But here, x is the first thing that happens. The increment happens, x changes into 2. So when we run it, we're going to see it print 1, final equals 2. We do it this way, we're going to see 2, final equals 2. All right, and that is the case. So, why would you care? One, you care if you are doing the plus plus in a line with other things. If it's on a line all by its lonesome, right, these do exactly the same thing. There's absolutely no difference about it. It doesn't matter whether this happens first before the semicolon or whether it happens last after it hits the semicolon, right? So if that's all you're going to do, that's fine. And if you're writing a for loop for x equals 0, x is less than 10, x plus plus, again, it doesn't matter whether you make it x plus plus or if you make it plus plus x. Because in effect, since this is after that semicolon, this is its own little statement, just like it was on a line by itself, and it doesn't matter whether it does it before it closes the parentheses or after. It does the same thing. But if you do something like this, see out, you know, x plus plus minus 2, and you think that you know what that's doing. Why you would do that, I don't know, but you could, right? And it's going to subtract 2 from x, whatever x was at that point, probably 10, so to print out 8. And then when it's done, x will have been changed to 9. Whereas if you prefixed it, the incrementing would happen immediately. Again, that looks pretty weird. Why would you do that? Most people won't. But you'll see in a habit of hardcore C programmers and C++ programmers who've looked at too many examples of this. People do things like this. While x minus minus do something. That's going to keep repeating until x becomes 0. In that particular case, I guess it doesn't matter whether it came first or not. But what if you were accessing elements in an array? Not that we really know what arrays are, but remember we had that string and we were accessing it by its element number, like that. In the other example, are we supposed to be accessing it from string position 10, 9, 8, 7, 6, or were we supposed to be doing 9, 8, 7, 6, 5? Did you want that minus minus to happen before it accessed that position in the string, or get changed afterwards? The simple way is just to avoid doing that and always do it like that, right? Then you don't have to sweat it. And if you get more complicated than that, you just better take it upon yourself to learn the difference between putting a plus plus before or after. Now, one weird little thing is that it's like a couple of nanoseconds faster to do the prefix version rather than the postfix version, which is absurd. But if you write a program that like increments a number, you know, a trillion times in a row, you will find out that that is the case. If you write something that'll track its speed, it gets done a little more quickly. Is it enough to worry about? No, not really. Not unless you're trying to write, you know, some kind of graphics driver, you know, for your Radeon that's supposed to, you know, calculate things as fast as possible. But you'll see some programmers religiously put the plus pluses in front of the variable just to get that little nanosecond speed increase out of it. Well, this is a good illustration of a loop right here, starting at 0, going up. Let's go ahead and print out the results there. It's going to print 0 up through 9. Why is it starting at 0? Well, that's pretty easy because it's starting with a 0 there. Why is it going to stop at 9? Because once it hits 10, it no longer goes in here, just like this said if x is less than 10. Once x is equal to 10, it's not going to go in here. So if we run it, we'll see the output 0 through 9, along with whatever silly stuff we were printing out. So that's a for loop. You can also do the same thing with a while loop if you wanted to. You could set x to its original value and then do while x is less than 10. Although really I like less than or equal better, and so I might probably do it. That might be my preference, right? 9. That was supposed to be a 9. Thanks, keyboard. And then see it out and then increment it. Now personally, despite that nanosecond speed increase you get by putting a plus in front of it, I like doing it afterwards. There we go. This is the same, by the way, as doing this in Java. Excuse me, in Python. If you've seen Python, you've done that before, right? X plus equals 1. It's just an increment. And there we go, right? It printed 0 through 9, and then it printed 0 through 9 again. Those are two different styles of loops. Both of these are called pretest loops. This is a pretest loop. This is a pretest loop. What does pretest mean? It means that the test happens before the body is executed. This checks to make sure that x is less than 10 before it prints it out. That's why we get the output 0 through 9. That test happens first. But there's also a post-test loop. And this did not exist in Python, so if you've only had Python, this will be a brand new thing. It's called a do loop. You still set your variable ahead of time, x is equal to 0, and then you can see out x and then ENDL, and then you can increment x, and you keep doing that while x is less than or equal to 9. Is that going to give us the same output? I'm not convinced it will. Let's find out. Post-test loops break my brain a little bit. Yep, it did the exact same thing. So why does that loop why would you ever even want to do this? Because the body of this loop is always executed at least once, no matter what. So if you set this equal to some arbitrarily high value, like 100, and then you run it, it's still going to print something. It's going to print 100. Whereas if this was set to 100 right here, it's not going to even go into the loop. Pretest, right? While x is less than or equal to 9. That's like an if x is less than or equal to 9. Well, it's not, so it skips that entirely. It does not skip this entirely because the test doesn't get around to happening until the body has executed. So this is a post-test loop. So when do you use a do loop? When do you use a post-test loop? When the body needs to occur at least once, no matter what. When do you use a for loop? You use a for loop if you're going to be stepping through a series of values, a known series of values. When do you use a while loop? When neither one of the other cases apply. There's nothing you can do with a for loop that you can't do with a while loop, and vice versa. They are completely interchangeable. This is just a nicer syntax, right? Because it initializes it, it has the comparison and the update all in the same line, whereas this has it in 3 lines. The initialization is there, the test is there, and the update is there. It's spread willy-nilly throughout the code. This has a nice little header that defines all 3 of those things. So the for loop is nicer to write. But you don't have to use it. You could write everything with a while loop if you wanted to. And again, you could write, with a little bit of twisted logic, a while loop that acted like a post-test loop. You'd just make it a while true, and then you'd have some statements in there, and then you'd have an if statement that said if greater than or equal to 10, break. But most textbooks don't show while true loops. It's interesting that the scripting textbook does, but the fundamentals textbook in this one does not. But what would that look like? Just to show y'all. I'm going to change those back to 0 though, I guess. Or starting off at 1 or something like that. X is equal to 1. And then while, parentheses true. See out x, yet again. Add 1 to x. And if x is greater than or equal to 10, it's time to stop. So break. That makes it a post-test loop. It behaves identically to this one. So if we put 100 here and 100 here, it's going to print out the number 100. It's going to add 1 to it, and then it's going to exit the loop. It's going to exit the loop here because of the post-test gatekeeper there. Kicks it out when it's hit 100. And here, there's no condition at all to break it out, but we have an if statement that'll break. So when we run it, we're going to see the counting 1 through 9 or whatever, and then we're going to see 2 100s in a row from the post-test loops. Like that. And so I guess that's the reason that the guy who invented the Python programming language did not even put post-test loops in there. They did not put do loops into the language because you can implement them all the same thing with a while and an if break. Whatever. So when to use post-test, parentheses do. if the body must be executed at least one time. When to use a for loop. When your code will iterate, fancy word, just step through a sequence of values. When to use a while loop. For everything else. So really, I almost never wind up. When I was a professional programmer, I never used do loops. Very, 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 very rarely. And if I had to, I probably coded it like that, just because that's the way that my brain works. And you don't have them available in all languages. But if you had a body that had to be executed at least once, no matter what, you could write it as a do loop. Minus minus works the same way as plus plus. It can go before the variable or after it, prefix or postfix. Same rules apply. If it's a prefix, the variable is immediately updated before anything else happens. If it's a postfix, it waits until it hits the semicolon before the change happens. Waits until after the statement is already executed. So, you can use them in expressions like this. Result is equal to num1 plus 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 minus minus num2. It's kind of nuts, but you can. If we set our values, if we set num1 equal to 10 and num2 equal to 10, what would the result be? Well, num1 gets updated, but not until the entire statement increments, right, executes. So it doesn't change. So the result is equal to 10 plus minus minus num2. The minus minus first means that it's immediately decremented, so it's going to be 10 plus 9. And so the result's going to be 19, and then num1 will have been increased to 11 because of the plus plus, and num2 will have been decreased by 1 to 9. So we'll have 11 stored there, we'll have 9 stored there, and the result will be 19. You can't do this. Looks like you ought to be able to, right? Well, I'm just going to add those two numbers together, and then I'm going to add 1. No. If you want to add 1 to it, add 1, right? Because what does this mean? That explicitly means x equals x plus 1. That's explicitly what it means. And so if we had that, what it is trying to tell us is that that is equal to that plus 1. Well, which variable is supposed to be changed, right? This is gobbledygook. It would not compile if you tried to write it like that. So it must be applied to something that has a location in memory. It can only work on variables. It can be used in relational expressions. Of course you can. Add 1 to num and then compare it to our limit. The while loop. The format is while followed by an expression and a statement, right? And if the expression is true, or as long as the expression is true, statement or block keeps repeating. If it's more than one line of code long, you need to enclose the block inside braces. If it's only one line of code, then you don't have to put braces there. And if you put a semicolon there, this is an infinite loop and it will hang your program. It's real easy to do too, because you get used to putting semicolons everywhere. But just like it breaks if statements, it also breaks while statements, but in a worse fashion. Locks the program. Why? Because it's treating it like this. While the expression is true, please do nothing. And then nothing ever changes it, right? Nothing ever changes the value of the expression. So if it was true to begin with, it's going to stay true. So it's an infinite loop. You just have to train yourself not to put semicolons after if statements, while statements, or for statements. So this is either going to be an expression like x is less than 10 or something like that, or it could be a Boolean variable. You could do something like this. X is equal to 10 while true, or no, and then bool valid equals true, And then while valid, while the data is valid, start doing stuff with x. I don't know what. X plus plus, x equals x times 2. And then when does the data become invalid? Once it's greater than the value 200 or something like that. I'm just making this up. Valid is equal to x greater than 200. So it's going to keep doing that until x is greater than 200, because this variable will be set to false. That's not right. This should be while x is less than or equal to 200, because that's valid data, right? Tell you what, let's make it look exactly like the other ones. So let's see out x. Let's add 1 to x. And let's make our condition while it's less than or equal to 9. So I hope you understand what this is doing. This is a Boolean variable. This expression is evaluated, and if x is still less than or equal to 9, then valid still equals true, and so it will repeat it. But once this expression is no longer true because x is no longer less than or equal to 9, that becomes a false. And so when it comes back and reevaluates it, that leaves. Would any particular reason to write that specific loop in that fashion? No. But there may be some reason that you want to drive a loop based on a Boolean value rather than on a specific expression. Maybe whether something is valid or not is a fairly complex calculation, right? It may take 3 or 4 steps to determine whether something is valid or not.
And that again is another post-test?
It's actually,
In a way?
yeah, you're right. This one is a post-test because it would do this no matter what. You're so right. If you wanted to make this a pretest loop, then you had better have a priming evaluation of valid before you do that. Does that make sense? That would convert it into a pretest loop because the check would happen before it went into it. Good point. Good point. Logic of a while loop. While this expression is true, do the block of statements. Whatever number starts at, if number is equal to 1, it would print out hello 1, 2, 3, 4, and 5 times. If number was set to 2, it would only print it out 4 times, right? Because it would print it out for number equals 2, 3, 4, and 5. So that's 4 times. If number had been set to 5 as it came in, it would only print out once, right? Because number is less than or equal to 5, so it would print out hello once, but then that increment would set it outside of that condition, it would fall through. And if number was equal to 6 or anything else, then it wouldn't print it out at all. Why don't we stop here? Okay, so your homework will in fact be to take this code that we did for the keypad, and I'll copy and paste it into the homework assignment for the texting, and you're just going to have to add the rest of the cases, right, for the rest of the letters of the alphabet. And if you feel like getting fancy and handling punctuation in some fashion, I don't know how you would do that, but you could figure it out if you felt like doing that. I'm not expecting you to. Come on. Really? Picture just looked like it would be hanging out there for us to grab. No, I'm not seeing how to do the punctuation. I know that there's a way that you could switch into punctuation mode then. They should have made the 1 key all the punctuation, right? Hit 1 for a period, twice for an exclamation mark, 3 for a question, 4 for a semicolon, 5 for... Anyways, let's not do that. Okay, so let's make a Dropbox and we will be done for today.